Now we will open AutoCAD. لا ده درافت سايت another software the same company of Solidworks of the SOO a product of the SOO the same as AutoCAD
same
it's the same now we will draw the station these components of many station and check the clearance between these large pockets. Okay, so first we need to get these pockets into SolidWorks to be a sketch and will be our gauge. After finish we will put it in assembly and check clearance if okay, if not okay, if something not good. First in AutoCAD, not in this draft site, that's the same. That anything that I will apply now in this software will be applicable in AutoCAD at the same time, not problem. Just I need to apply this important view on a specific layer alone. Look. Have a specific layer, okay, Control S, save it in WDWG, thank you.
In AutoCAD you can say which layer separate or not?
Station already named, yes. But you have the same name. Should cancel it. Okay. Now this AutoCAD DWGS will be dragged into SolidWorks. Concentrate with me only in this action because how to import a DXF into SolidWorks. Okay. Import a new part as a 2D sketch. Now we will import the AutoCAD file, this layer, as a sketch, 2D sketch into a part. Okay, next. Now check millimeters. You're working in millimeter, yes?
Yes.
Sure? Yes. Okay. And select your layer. I need this only block. Right? Okay, any problem? No. Nothing, it's okay. Good. Next. Finish. Yes. Now has been imported. Right click. Fine. Merge. No problem for us. Now check dimensions. Tell me if okay. With the same of AutoCAD, yeah? Tell me it's okay?
Yes.
Set dimensions. If any change, tell me. Because it's a real project, huh? Not training, huh? Alright. So, in this case, I don't need also this frame. Doesn't important for me.
Well, but
Why?
to draw the full cabinet.
You already manufactured. You problem in small cabinet. Yes or no?
Yes, you have the back door connected to the main.
Ah, you have a back door. Okay. So if this is important for you, because you will manufacture something dependent on this cabinet, you can do the following. Not in this way, the same way, but we need something. You should do DWG file,
You
yes,
cannot import all
old one.
the drawing.
Yes, I can, but why? But yes, I can do that. Just a block, backend.
And the size of the cabinet we will take it from there.
Yes, this views.
The base.
Okay. You can do another thing if you need.
Here you will draw on parts or you will draw on
Yeah. If you would.
components.
No, we're drawing part, this first part, and the door will be another component into assembly. The door will be alone.
Sorry, you draw in parts or you draw in assembly?
No, I will draw in parts or assembly according the compatibility and if
Why to
difficult
draw
or
it
not.
here and why to draw here? Assembly, if you draw from assembly,
As the same, but if you have a big relations and collisions and you need to check 20 parts together.
this one like have,
But this one is very, very simple. You having to do like that.
but you don't need to draw it part by part then.
Because
make
also I
assembly.
have the DWG. My main problem if I don't have a DWG,
Then
I
you
have
draw
just
it on
dimension
part.
from
Yes.
paper.
On
But here,
assembly you can draw draft also.
yes, I will use it in the main cabinet, in the main unit cabinet, yeah. Because I will draw automatically, not from DWG, or automatically files as bended, not flatted. I will convert it from bend to flat, not from flat to bend. Okay. So now the same. Import to the. You can import dimensions. Millimeter. Select import dimensions. You will get this. All layers. Okay. Import dimensions. Okay. Finish. Okay. If you have any dimension written in AutoCAD, like that, these dimensions will be imported also into Solidworks, and you can change it. We'll use it as a smart dimension. Will be automatically imported as a smart dimension. Okay, not just a graphic, not just text, right? Now you will start working. Okay. Now we have a lot of.
Look, to explain to you.
Okay.
This is the plan.
Yes.
This is the top view.
Mm.
This is the depth of the cabinet, and this is the width of the cabinet. Yes?
Yes.
Okay. This one is already included here, plus the banding inside.
Mm.
So you need to put the center of this to the center of this, and this is where will be the size of the cabinet. This one. The remaining is all for banding. For you just to know about.
Yes, I know.
Okay? And this one, this size, is sitting in the middle of this one. Middle center here and middle center. Yes? Center to center.
Okay. Now, in this case, you will open new part. I think this would be better to be printed because not serve me with this way. Will not serve you in SolidWorks with this way because you will not use this as a drawing. Okay, I just use it as a block and I will see what I will do. Okay, you can measure.
If template the base, it's not
Okay, measure this
60.
680.
Yes. 680, yes.
Yeah, it's external. External, yeah.
External
Different
dimension
external. So,
by 20.
okay. So, you will open a new part. A new part in sheet metal, the concept is different, but it's very simple. Next, top. Now, I need this. Within the dimensions, not important actual dimensions here. Middle. Again, right click, midpoint, shift, point, constant. The same relations that we made before. The same. Okay. Now we use the same commands, no change. It's just a sketch. Equal. And not equal only. Collinear. Do you remember collinear? Yes, do you remember? This will be, and this will be. This will be equal. We can review dimensions. Windows. Evaluate. Okay.
Measure these.
Isn't important for me because it will be 20 sure. 25 is it 25 by 25?
25
By 25 or by 20?
That we need to measure. Measure the other one. This big one.
Which one? This?
Yes.
The bit is the same.
No.
25.
I mean, measure. Measure. Zoom down. Zoom out. Measure from here to here.
$165, but would not serve us this one.
165.
Yes. Will not serve us this dimension. I need this.
Oh, sorry. You need to measure this. From here should be 68, then 20. The remaining is 2.5. Then you will know how much the remaining band.
No, but in flat you can't calculate the flatten from direct with your eye or with the measurement. We have something called the key factor and some deduction in sheet metal. If you have a sample, we can get it to be accurate. The sample. How much an ounce?
2.5.
Yeah.
No, but we always want the outer side. It doesn't matter how it is. I need it, let's say 2.5.
Where is 2.5?
Here.
25?
Yes.
This is 25, okay.
Yes.
And the
Also, you need to work on based on the sheet. Put the other side 25. No, not here. The other side. I mean.
Other side? Which one? This? This from top. Now we are on top.
The top 25 and the other top 25. It's automatically 25.
No.
No, not this one. Not the inside. This one and the other side should be the same.
Other side is automatically as
Okay,
same.
so 25. Yeah. 2.5 plus 2.5.
Yeah.
Plus 40 plus 68 equal 113. How much our sheet?
125.
Can you measure the sheet? How much it is?
No, not now. After flatten. Get the thickness and the flatten.
That man, I work based on the file, then I bend. Based on the sheet size, then I bend. How much? Maybe the bend inside will be 3 cm. Maybe it will be 4 cm based on how much I can use the sheet. Yeah, can you measure the sheet outside to outside? 170.
Yes.
So you have 117 minus 68 minus 20 minus 20 equal 9. Minus 5, 2.5, this is 5, so remaining 4, so it means 2 cm. So 2.5 by 2 cm.
Okay.
عرفنا أي كونسبت بيشتغل
Mhm.
يعني you have laser.
Okay.
I know it shouldn't be after you will modify, but let's draw it one time correct, but this is correct. Let's say 20 and 25.
Okay, sheet metal thickness, how much?
2 mm.
Height?
170. 170, yes? Minus 5. Measure the sheet.
Okay. How many thickness?
2 mm.
Okay. Is the actual bend, actual flat.
Can
Actual
you
number
measure
of flat.
the actual one? What is the height?
Okay.
Might not be 170.
Height from here to here?
Yeah.
You have any pens in this? No. Okay.
170.
170.
So it's 170.
Okay. All right. P001-00 from ST 235 steel. Yeah. The type of steel. Okay. Now we need to apply all openings, cuts here and that. We need to copy these cuts on this surface. Okay. Now you have something called the block. What's the block? If I will come with this and get center line here, okay, remove it and remove it and get it center line. Remove it also, remove it without changing dimension. Take care, and I will be vertical, horizontal, vertical, horizontal, and you can also fix it. Fix. So having dimension, you can fix. Okay. Why I made this center line? Because my reference in this model is a center, not edges, because edges already bent. Okay, so I can't copy from edge. We will do something. This one, these items also can be fixed. Something called the block. What is the block? B-L-O-C-K, like AutoCAD, block. We need to make block from some entities. We will block some entities in new file as a block, not as a part drawing. We can move it in each project you need. If this project will be repeated in other sizes, okay? But these blocks are fixed. Now make block. Make block from what? Make block. This no. okay. Select.
You cannot select like this.
Yes, you can, but I show you only working calm. And this, why this? Because this would be your reference in tool. Because if I will copy this cavity alone without this, I can't keep in my mind this number. May have an error. Okay? But when I will copy the axis, this axis have a original tool, original length. Okay? So this point, when we put it at the top of the cabinet in 3D, will be the same position, as a gauge. فاهم علي قصدي؟ as a gauge. And go okay. Blocked. Just blocked. See? Right click, save block. Here you go. Now you can save block anywhere in the same folder of block station. And I will give a name. Cut. Box dash opening. This extension is strange because the Solidworks is block, not part, not assembly, not drawing. Save. Okay. Go. Here, type also block. Insert block. Insert block. Or you can get from here, insert block. You can search, or block, insert block. He will tell you. Insert block. And select the face which block will be applied. And browse. Go to charging station. It's okay. Escape. Take this block and go to the middle. Tuck. Finished. It's the same place. Okay. Out. Just cut. Just cut. Okay. But in sheet metal, there is something add. Link to thickness. Because sheet metal already have a thickness. No sheet metal in the world having thickness. Okay. So I will link to thickness. This will be appear only when using sheet metal module. Link to thickness, it will do a fixed equation. Okay. This fixed equation that if I will change the thickness, the cut will be through. The cut will be through, like through all in normal working. Okay, finished. Cutting as same. We can go to edit. Just to check that here we have a problem. Yes, in middle, not moving. Okay, all right. As I said. Okay, moved it. Control S, save, close. File, new assembly. Import this new one. Assembly. Fix it. It's okay. Check position with this. Maybe okay automatically, because from step 1 we working the part in the middle of plans. Okay, so we import it in assembly, will be imported with the same position. Okay, so you don't have to make a hassle of mates and relations. Okay, this one. Let it, fix it. Don't move. You don't need it move. Continue working from assembly into new parts. دي بقى الحته اللي جت عليها. تبدا بقى تبني اول واحد بس، بعد كده تخلص كله على بعضه. second part ايه بقى هتعملوا تاني؟ راكبه ازاي ولا ظروف؟
توب اند بوتوم. هاي دي
لو ده
لف فيه.
اوكي.
شوف كيف جاي شكله. This one ركبه من التوب.
ملحومه؟
تعمل straight. This is the front.
الصح حته لورا.
اعمل هاي هاي هاي.
اوكي.
So هاي وهاي فين الفانسي؟
ايه؟
فين الفانسي؟ توب. دي تعمل له جروب. لأنه هم عندك سايد. باك سايد جاي سايدين، تو سايدين، صح؟
اوكي.
جاي هذا النظام. توب one piece, which is this one. This is the top. Because you need to band inside, the band should go in between these two. So زلفية ننهار.
اوكي.
بعدين نايتها لجوا كمان.
اوكي.
You add
تعجر جوه
a little bit.
بس كده.
هون here how to
تعجر
do.
ثانيه.
هون you already band here you already
The same.
going inside. Here there is a pin for the door.
That's okay. Pin not now. I need only to take this out.
This is the thickness of the cabinet, which
Okay.
you already have.
Okay.
انت بتعمل التوب.
Will be on the top.
These
yeah?
two parts, one top, one bottom.
Yes, yes.
This is the bottom because you have
Have a fans, yeah.
This you don't need. What
Okay.
you need is this one. This is the size of the top. Then here we band it. Here it should be the same band, 2 centimeters, so same as we did the last one. So this you take 2 centimeters you band, and the remaining distance is what you see from the back side.
Yeah. The door above support and door down
And
support.
bottom support.
And this sheet metal top face into this or above?
Above.
Above.
Yeah. So in this case, we will draw all at once with a clearance with insert component. There is something called new part. New part. What does it mean? Means that I will create new part, but this assembly will be remain at the front of you, because you can take from here, take a reference of dimensions of this area, the clearance between them, take this dimension as a reference. Okay, so new part, he created automatically new part here, but a blank part, nothing. He asks you one question: where is the first plan? Where is the plan, the base of the new part? The base will be at the top of this. Click on any face at the top, according to position you need. See what does it mean? You know the calc, the transparent paper? Okay? It's like transparent paper. If you have a paper and you draw something, and you need to draw another thing related to this drawing with another paper, you will come with transparent paper and put it inside white paper with drawing and take your reference.
Copy.
Okay, copy. Okay.
Call it in the field is onion paper.
Onion paper. Yes.
Yeah.
It's onion paper.
The same concept. Now you can't modify anything in this panel. No, because the blue file, meaning this is the active file. This is the active file working in it now. This is new part 50 ISM3. This is a random name. You can change it after finish with your coding. Okay, but the first one only as a reference. You can take a dimension, okay, make a relations, make a equations, as you like.
You cannot change.
You can, okay. Control 8, automatically he went and opened a sketch. Now you are in the sketch, in the newest part. You are on the sketch in this new part. Control 8 and start drawing. Now I will take a reference, not from AutoCAD. I will take a reference from this drawing directly. See, convert entities. 1, 2, 3. 1, 2. Sorry. Thank you. Finished. Finished. The problem. Now, also, you will close it here and horizontally. So this one with this one will be collinear. Okay, and you can finally get this the same round. So you can do that. Delete it, you haven't need. Go with convert entities. This round and this round, okay, and go this tuck, okay, okay, make a line from here to here. Thank you. Don't need any more. Go. This selection, it's okay. Sheet metal up 2 millimeters also, yeah.
Yes, everything is
Good. And go on. Now I'm out to assembly. Return to assembly. Right click, edit part. See this. Right click on the part. Edit part. This icon meaning that you are in a part in assembly. You are into a part. Okay. To know the part, which part you are into, will be marked with blue. Okay. So now you can continue. Okay. Let's continue. You can change shade from here to this way if this will be better for you. Edge flange pending,
but not on top,
can change.
inside.
You can change. First, before identify, edit flange, right, and this line. Okay. Also are still into part, right click, edit, and put it inside and change your dimension. See this action will do. Now this dimension should have a clearance. This clearance may be 0.24 millimeters, at least 0.24 from each side. This means that I will get smart dimension. Get this and this 0.24. Get this here and smart dimension 0.24. And it's okay, no problem. Can put any number you need and you can modify again. For example, now finish. See? And this face with this face immediately having the problem. It's the same. Same. Okay? Why we did this relation? Now, if you,
Want to
Mr. Khaldoun, need to change this. So, if you change this, you need also to make some changes. You need to change this cut and the another cut and the door size. All things will be changed based on this 25. Now, if I will change this 25 to 100, unbelievable number. Divide. Because you already keep the 0.25 from each side. Okay? All dimensions are related together. This means that only you just take a time to build your model accurately, so any change will be very easy. Take seconds, not minutes. Okay. This 25 is okay. Ctrl Q, refresh, or traffic. Open part. Again. Right click. Edit part will open the part with the other assembly. Okay? If right click open part will open the part separately.
if what?
Right click open part, not edit part.
Oh, okay.
Okay.
Full part it will open separate.
Yeah.
Edit part it will show the main item.
Because if I need to modify this, I haven't any relation to modify this 100 because I know what I need. So having to modify it with the hassle of parts, so you can right click open part and modify. Where is it? Yeah, it's very easy. How much? Well,
Open the measure.
165
Minus 2, 163.
minus no minus 20,
Minus 45.
No,
45 watt.
Because you put like this inside.
you need to only reduce the 20, then you will get the height.
If we can measure with caliber. These samples is okay, are okay. These samples okay. We can caliber to it, and we'll know. That calibration. I need to know how much and how much. Only that.
You just check the top how much and the siding how much.
بدل ما نقعد نحسب في فلات خلينا ناخدها على الواقع اللي اتعمل كده كده انا هطلع فلات. Already Solidworks will be generated flat and DXF.
This 165.
Which one?
Now the existing is 165.
This 65 instead of 100?
No, it's 165. Yes, you said 165 minus 2.
165.
163.
Yes.
After 163.
Not 2, not 20.
2. What you already did the top.
Just top like it's 20. No, I didn't 20. This 200, 20 millimeter. This is 200 millimeter.
Yeah.
It's okay.
Yeah.
Okay. And about this side, how many these which I will make a bend here.
The
How
band
many?
inside is 20, so remaining
45, 20,
how much?
445, and then 20.
145, then 20.
Yes.
145.
Then 20
Yes.
inside.
Okay.
Yes.
$20.
Yes.
Okay. Internal, yeah. This means that this 1.145 internal, external,
Inside.
external to external,
Then
yeah.
20 external.
Yeah, and also 20 external. So if you can review, measure, from here, evaluate, measure, just this face and the other face. Yes, it's okay. Check this face to this face. 20, it's okay. Right click, steel. Second part.
You need
Now.
to mirror top to bottom.
Yes. Now you will change name, copy, just click, like renaming in Windows, like folder renaming in Windows the same, and put new name. 2. Save. He will ask you. You must know something here. When he asks you, save internally and save externally. When we start a new part into assembly, by default will be internally. Meaning that now if I will close this file and I will save internally and close. Okay, close. You will see only in 3D assembly and the P001. Now where is the P002? Not found. Not deleted, but already saved in assembly, into assembly. Okay, why is this action? Have a philosophy of design. Now you're drawing from parts in assembly. So you may have a new design and you start thinking, may change, may delete, may something like that. Okay, I may delete this file. May. If this is the first time I'm working on Solidworks with this project, I may, after drawing, I will delete some components because I need to modify, I need to add, I need to remove. Okay, so instead of saving all parts immediately externally and make a big hassle of files, and finally you don't know, you can mix between files that you need and the files don't need. It's okay. First time he working internally. If I decided that's okay, I need this file, really I need it, when I save, he will ask me, okay, externally or internally, still internally. I will tell him no, externally. This file will be already copied here. Okay? If you also need to make it externally without saving, before saving, you can right click, save part in external file. This is strategy working with anything, working with features, working with sheet metal, with weldment, with anything. It's a software strategy, okay? Not communicated with sheet metal.
For a reason, if you need to split the material for suppliers, let's say you have a bearing, so then you can have this bearing or this component that you will produce it outside. You just save it separately and then send it to the
No.
supplier.
Okay?
Yeah, but for sure it needs to be all internal.
To be all internally, but when you create drawing and workshop, something like that, it should be external, because the workshop drawing not be able to be done when this file is internally. Because when this file internally, this means that this file unreleased. Unreleased.
Still not yet done.
Still unreleased, yeah. Under construction, under modification. Okay.
But better draw it all, finish it, then the export
Yeah, if this project is something new. But now you have an idea and you know the dimensions and we work in green. No change because you already made the manufactured. So haven't a problem to external. Take care also from internal files. When you make it internal, the file itself, the assembly file, would be big size. Okay, if your computer can support this big size and you have 200 or 100 or 50 or 50 files internally, you may feel that assembly not working good, make a mechanical motions. You know this in Max, when a file will be large, you feel you can rotate, you can't rotate, tuck, 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 tuck. You will feel the same. Okay?
But this file should be big.
No. If you can check.
We are doing the building, yeah.
This file, nothing. 58 kilo. Nothing. And these files together, 2 parts and soil. Okay. But one file have a multi cuts, multi holes. Okay. Take care from holes. If you have a project like your curve externally, if you have this assembly on the Solidworks, you have thousands of holes. Okay. Take care from these holes because these holes, each hole have a million of points. Okay. When you cut 100 holes, 200 holes, you need a supercomputer. It's the culture of software, not a problem. Culture of software.
Yeah.
Yes. Not SolidWorks only, in SketchUp, in 3D Max, in 3D Max, when you change the mesh, when you change the number of meshes, okay, of the product, yes, you see it very, very smooth, but it's very, very heavy at the same time. Okay. Light file, poor quality. Heavy file, good quality. Okay. Okay. Now the port. Where is it? Okay. Now this port, which have the cuts or cutouts of fans. Okay, the same dimension, but only have 2 cuts. In this case, you haven't to do another port. There are something called configuration. Also, this configuration concept, working with each thing, feature, sheet metal, surface. What's the configuration? If you review the features, right click, open this part. If I will come and make cut, note here, sorry, cut in there, and make 2 boxes. 2 boxes like that. And create center line on this red one, and create this. We can change, no problem. And this we can change. You can get something good. This equal. Eh?
Make it solid. Bring the plan as is. You can.
Like block, yeah? Yes, you can, but not need it just to.
And have 4 holes each. Go down.
Just to.
This one.
This one? Yeah, just to. I can measure without any problem.
That one is not
Distance
in the
between.
middle.
Eh?
That one is not in the middle.
Distance between them 84, and distance between them is 283.65. No problem. You can just right click copy. Okay, and keep in your mind the other number 84, not a big complicated. sorry. See, we opened an error in the wrong place. Okay, so I will go again, opening.
Cannot rotate.
Yes. Go away. Cutting it anywhere. You can go here on the sketch. Here you can edit the sketch. Okay? Here you can edit the plan which you selected before your first selection. Now we select this face. No, I will select this face. Only. Have some error in cutout, no problem. Okay, edit. The same. Haven't anything, any problem. Okay, and we have here, from here, paste Ctrl V the number. Okay, now, and this point to this point. Okay, and this 84. Okay. Now you need make a symmetric. So I need to these squares in the middle of this center line. So right click, left click, sorry, shift this, still press shift, and this empty, symmetric, entity, center line, entity. What's the relation? Symmetric. But take care, you can't do symmetric with this type of line. If you will select this and this and this, no symmetric, not be found. Not be found. Why? He think that you need symmetric because you have this line is a center line. Okay? It's artificial intelligence. Alright. About this, no problem. If this is in the middle, مش كده? So you can create a line from here to here. Just line, no problem to be fixed. But right click, midpoint with this point, okay. And this is a reference, no problem. You can move. And go to right click on the cut to know what's the problem in the cut. Just okay. Sorry. The other side. This cut feature only, if I will remove, suppress, will be the upper one. If I will unsuppress, the lower one. Okay? But how can say to the software this action? First, you can make mirror. We can mirror it. How can mirror? We can use, we haven't any middle plane. We need a plane at the middle of this tool. Okay, here. Sure, but we till now we haven't any of our drawings have a middle plane. But we can create a plan in assembly. How? As you create in the part with the same feature, with the same option, name, haven't a problem. You will find it where? Yes, reference, the same menu. The same menu. If you can compare this menu with the other menu found in new part, you will find it the same. Sorry, yes. The same. Plan, axis, coordinate, system, point. Close. Plan, axis, coordinate, system, point, and this is A for assembly, another additional options for assembly. Okay? So, as I say, plan. But this plan will be at the middle. You can say to me that yes, we have a tool with 1,700 divide 2 from each from any side will be okay. Yes, you will be right. But if I will change this 1,700, the position of plan will be changed.
So your coordinate is the center of the eye.
So we need to concentrate it in the center.
Center
center.
of top plan or
Yes.
side?
So you can make right click, isolate. Do you remember isolate that we made in bodies?
Or hide, yeah.
Isolate. Only I need this. Will hide all others. If you also have thousands of parts.
Where
Isolate.
you click first?
Right click on the part that I need to be
You are
shown.
first in where you are in the item, yes?
What?
You are now where?
No, mouse here.
Yeah, but
No selection. Having no selection.
you are in assembly.
Yes, I'm assembly. Yeah.
Okay,
Yeah.
you are in assembly, then
Yeah.
you click the part,
Click on the part and isolate it.
isolate.
Isolate it from the others. You will show it only. Like in some
If you
software, it's called
click
show
on-
only, hide all, hide only.
If you click the other part and you put isolate, this one will disappear or no?
Yes.
Like this.
Isolate.
Isolate. Sorry. Right.
Isolate means
So you isolate totally everything except the part that you click.
Yeah. Also 2 parts, 3 parts you select. If you can click here and click here with shift, right click, isolate. He will, if you have thousands of parts, he will isolate the parts only you selected. Okay?
Shift or control?
No, shift. Okay. You can use control, but when you select far away parts, part here and part here and part here, okay? Because shift like window. If you have files like this, yeah, you know, shift. You select all others, but control, okay. Right click. Okay, right click, isolate, and click here, plan. Just select the top face, bottom face, nothing more. He will create automatically a plan between them. Nothing more, nothing option, no option selected required. Okay, thank you. You can take a plan to show only. This haven't any effect on drawing, just for show, to show that you have a plan here. Okay, and exit isolate, and this plan is okay. Yes, you can mirror. Where is the plan? This one, this part go. It's okay. All right.
Top view is open, yeah?
Yes. Still opening. Not closed.
Not, the top don't have holes.
Yes, I know. Now, if you need, as you said before, that we need to separate these files, separate these parts, but not separated. Separate and not separate. I need to separate them only in this cutout, but still dimensions will be in link, because this file is called number 02, mirror 02. So these files are a copy from each one from them, and not a copy, as the same.
What's this mates?
Not mates, mirror.
No, up. Yeah, what is it?
Haven't no, this special mate. Any file you can create as a new part in assembly have this mate, this sign that this part has been created in assembly, not created individually. Okay, just sign. Alright, now these parts are the same, P02 P02. When I will change this number 03. Okay, has been changed 03. It was the same. Okay, thank you. Okay, save. Okay, so you have only way to do that. What's the way? When you will go to the part, there are something here. There is something here called configuration. What's the configuration concept? Let's explain something. When you buy something like containers for cooking in your home, okay, you found the same container with multi-size. Okay, when you buy it, buy multi-sizes, but the same design, same hands, okay, same cover, same shape, only change the sizes. Okay, this is called the configuration. You have a same design, but multi-configurations. Okay.
The configuration can be in the shape and the size.
Yes. Configurations in mechanical wise and design or shape design can change shape. You have a multi configurations from this table. This means this table design is okay. It's the same curves, the same spirit, the same materials. It's okay. No, I change only size, heights. Okay, the same design of this curve. Okay, this is the only table. Called مثلا وليكن called any name. Ali tables. Okay, Unigraf table. Okay, any name. But have a multi sizes. This is called the configuration. I need to configure these. No, this table have a rectangular cut. Another table with the same have another configuration with circular cut. Understand what does that mean? Understand or not? Okay, you are okay? Okay. So we will need the same. We will do the same here. The same exactly. Okay. How? Okay.
They have some designs. We need to exit. We will explain to you after what this.
Okay. So this configuration, you can do that. How? Now you have a default. By default of software, this configuration called the default. No, we need to give him a code. This opening without opening is a top. Okay, we click top dash cover.
Bottom.
No, without will be top. Yes. Okay. And right click, add configuration. Bottom cover and click this suppress. We will explain not now. And go to properties of top and unselect also suppress features. Top, double click. Okay. So on top cover active, I want top cover active, I will go to features and right click suppress. I suppress the feature, not deleted, just suppressed, inactive. Feature just inactive. Okay? Home bottom, okay. Top, not okay. bottom okay, top not okay. Okay, in bottom active, top inactive. Okay, alright, so exit and save. Let's go. The same component name, right click on it, right click, just right click, top cover, no, bottom cover. Understand? But it's the same port, number 2, P002, but this P002 with bottom cover, this 002 with top cover. If you will change the dimension, this one 45 to P50 together. Okay, 145. Okay, okay, clear. This is called configuration. You can use it in feature, in service, sheet metal, in weldment, in structure. That's it. Short more times, save times. Okay. I think that we not need other components because the door will be only from here.
You need the base.
You don't need it for drawing?
Yeah, I prefer to draw door before.
Okay, just go to door now and we can continue it.
After.
Yeah.
I don't know how to flatten a base, but I need to flatten the base.
Okay, no problem.
I don't need to put metal I'm putting steel structure and then covering the edge. But
okay.
if you do it, there is a way how to flatten it. Cut it all one laser file, then bend,
Yeah.
and then the curve you
No
can
problem.
overlap.
Okay. Let's go directly to the door and continue. Door. Now we will create something new. So haven't AutoCAD, haven't anything. Only we have a reference of this cabinet. Okay. We need to check the clearance of door. We need to install the lock and see the lock pin. Okay. Where can cut gaskets? How can we install gaskets? Okay, and the gaskets in compression and in normal state. Okay, with dimensions. Before cutting the place of hinge, okay, you should create the door first. You will create the door first. Evaluate, measure 630. My net space 630, and okay, you can yes, net with 630 by 1414.
1/4.
Yes, 1/4. Okay.
It's not.
Yes, it's a net. New file, because we don't not need reference now. Why not need reference now? Because the door will be movable. So we will put the door and open and close and check clearance. So you can get a reference in sketches like top and bottom. Okay, because when I will open, if I have a reference, I can open. The sketch can't move. Okay, no, I need the door free, and I will connect the door by equations, not by relations. By equations, not by relations. Okay, let's explain something before starting. If I have these two items. Okay? And I have this. Okay. This will be the door. Okay? I will check. This door will be a movable part. So you can draw this door like we drawn the bottom or the top of the cabinet, because the cabinet is fixed, not move, have it in dynamics. Okay, but the door have a dynamic. Okay, so you can't get a sketch with specific dimensions from here and here, because when you will open the door, okay, the dimension position will be changed. All right. So what we will do, we will draw the door from these dimensions that we wrote in the paper in a separated file. Okay. After that, we will bring the door into assembly, and we will connect the door dimensions with these dimensions by equations. By equation, not by relation. No dimensions, no sketching, just equation. I would say the W width of the door equal this size. Equal this size. If the door here will still equal the size. If here will still equal the size. Okay, this is the equation. Okay, haven't relation in drawings. Clear? Okay. Just like that. Give me dimensions, net dimensions. Okay. Sheet metal, 2 millimeters. أنا نفسي الشاي أكتر من ساعة
عندي شغلة أخرى.
Now 2 millimeters.
بس عجل شوية.
Okay. Right Greek material and sheet metal flange 1 والله 1 2 3 4. It's okay. Which dimension? 24? 20? Okay.
20?
Yes, 20.
Or less than? No, less than. If that one is 20, the door should be like 15. Can you check the door? Go to the okay.
Is there round cut? Okay. Okay. Our 5. I will know from this.
Yes. 15.
50. Okay. And will be internal, not external. Internal. This means that these dimensions include also the pins. Outside from outside, this dimension, and outside from outside this dimension. Without clearance now.
Yes.
Will be applied. Clearance will be applied. Okay. Before, we need to close this. You can close it by welding, but my school, I don't prefer welding at this point to be something like that. You can close it, and welding will be just points.
No, and I need the corners to touch each other.
Touch each other. Okay. You have something
You need
here.
to reduce the
Yes.
fillet, the chamfering.
Yeah.
The chamfer
Close
radius
corner. Yes.
reduce, so the side will
No,
become.
just with close corner. You see, this chamfer radius.
La, reduce the chamfer radius.
Chamfer radius.
So it will be as
0.8.
what I did. More. From
This-
inside it is almost sharp,
Yes, yes.
but
Corners.
from outside it is.
Yeah. Corners. Closed corners. This. Thank you. You have multi options. This, or this.
This one.
Okay.
You need to select.
Just select one of them and they will select the others. Each corner you can select. And this is a gap. You should have a gap. At least 0.1, 0.05.
Okay.
With this accuracy of sheet metal, you can using 0.05 millimeter. Very accurate.
Okay, sir.
حبيب قلبي.
Okay, sir.
Thank you.
Okay. So 0.05 gap only. You can see with your eyes.
هلا what I do usually I do half circle. شايفها؟
No, this half circle. Yes, yes. But this welding. This is a welding. And
No,
this
not for one. Even
Ah,
for
this half
bending,
circle?
you cannot have the precision. Right? It will flip up.
It flip out, but if you have his tools can be go to entire. We're having this problem. Okay. Also,
You see how the
you can
edge?
you can do this. Yes, I know. This yes you can do, but if you have in his machine a specific tool at the lens into entires these pins, this effect will not be open. You will see it closed, having the problem. You just need to hammering, you need to close it.
Yeah, I mean the bend inside it never been 100% 90 degrees, and once it's not 90 degrees inside, it will never be outside exactly. Fine, anyway,
Okay.
it doesn't matter.
Okay, we can change having the problem. This is the final retouching you can do. You can do here also, not important to here in DXF. You can do here in 3D and will be updated in DXF. Control S. Save. And get this part, drag and drop. Yes. Now you need to move, rotate. Okay. Now we need to install this door and check clearance and get it in out. Before make a hole, we will assemble this door with 2 circles before cutting as a reference of drilling. Okay, 2 circles. We can draw in assembly directly, sketch on this phase in assembly, sketch in assembly in tone apart. Okay, and draw this hole.
5
5 what?
5
5, okay. And we can put it in any place within a dimension. Now, I want the problem.
20
Any dimension, we will check and the accuracy dimension according clearance. Have a sketch here. You can rename it with pivot. And add the door. You can have in this plan also. The same circle. And the circle will be at the middle of the door. And this circle has also 20. Not important, this place now will be changed according door. Start assembly. First, before anything. Mate. You should first, this door should be assembled, locked in this way. Okay, so I need to assemble it in the middle of these two covers.
Yeah.
Okay, mate, advanced, something in advanced mate, concentrate in this please, called width. This face with this face alone and on the box, another box, this face with this face, finished. This means that these two faces between two faces. Okay. First relation. Okay, width. Second relation, just select this sketch. On this sketch, concentric, thank you, finished. Now let's check. Okay, let's check. Before I check, we need to determine the maximum opening and the minimum closing angle. So I have a minimum closing 0, okay, but the maximum opening we should have something 90 degree
90 degree.
maximum opening. Okay, so mate. Sorry, before continue.